Dear students, in analytical geometry, various dimensions of equations you have seen in previous exercise and this exercise, but now we are going to see different application sums which we are seen in a daily life. What it is, you have gone to the shopping mall and hospitals and railway stations, all those places you might have seen and visited, and by way of going to the upstairs or 5 or 7 story building, you cannot go by walk. So you need some kind of access to travel. So those access are either by that pad, what is that escalator, or by lift. There are two things you have seen, but now this problem dealing with the escalator sum. Instead of lift, we are going to use escalator. How it is? Let us see this beautiful problem of analytical geometry in a shopping mall. There is a hall of cuboid. What do you mean by cuboid? What do you mean by cuboid? It is a cuboid having 3 dimensions, and it will have length, breadth and height. Is it clear? Length, breadth and height. And this cuboid with dimensions of 800 into 800 into 720, it may be a length, breadth, height, or a length, breadth or a length, height, breadth, like. So the units which needs to be added, the facility of an escalator in the path as shown by the dotted line. So the dotted line here they is shown. In your book it is very visually given with blue color, and the entire thing is given. Those dotted lines, the escalators are moving path. The path which is moved from one place to the destination, this is the origin and this is the destination. The origin, so called, we take it as O. The destination we can take it as D. So O, A, B and C are the path traced or travelled by the escalator and meet at D. Okay. Now the question is, find the minimum total length of the escalator. What is the initial point and what is the final point? We have to meet the entire length of the escalator, how much distance or the total travel, the distance that we have to calculate first. Second, the heights at which the escalator changes its directions, where the angle would changes, where the angle. So here it moves and immediately it sudden jumps to the B and again to C, again to D. Likewise, there are some kind of changes or twisted that change by the escalator. The shift changed by the escalator or the places are A, B and C. The shift or the directions which changes are A, B and C, and that is the place where we call it as, these are the places that we have seen. And the slope of the escalator at the turning points, and those places here and this, what would be the turning points? What would be the turning points? These are the things you have to remember. What are the things? First one, the minimum total length of the escalator. What would be the length of the escalator? Second one, the heights. How much heights? What is height at which the changes in directions? How much height it has been changed? That is what we want to know. And the final one is the slopes of the escalator at the turning points. That means the angle, the shift that changes. So we are going to see all that. So let us begin with this. Now, what are the moving points and what are the stationary? This is the origin and O is the origin. Let O comma D be the origin and destination of the escalator. The places where it moves or changes are A, B, C, D. Let A, B and C are the places where the escalator make changes. Escalator changes its directions. So we wish to know what would be the length. So the length we wish to calculate. So totally it is 800. See that. See, I have taken this model, very simple model and easy model. By seeing this one, see, this is assumed that it is a cuboid. This is a cuboid. Absolutely it is a cuboid. So this is a cuboid. So this cuboid, if I just break up all that, I am getting that four-sided. 1, 2, 3 and 4. These are the four-sided figure now. So that means I have opened it. So I got the four ends of this. So now this is origin. See, I have taken all the points of this one. The thread which I have just shown, that is the path of the escalator. Path of the escalator. See, this is O. This is the changes which occurs, and changes occurs at B, changes occurs at C. The destination is D here. See, this is the path traveled by the escalator. So from this model, you could see how the escalator moving from the origin to the destination. So now this is 800. See that. So total distance is 800 and 800, 720. So that means if I just, this is 800, the height also nothing but 800. So 800 here. See that. And this is 800. So everywhere it is 800. Since it is a cuboid and it is given 800 and 800. So this is 800. The other one is 800. Okay. It's very clear and very simple way you can calculate what is that. So now this part is, now I have shown you this one is an analytical proof. This you have to write in your examination. So in your examination you have to show how this one would be. This is nothing but what is that? It is totally, it is each one is how much? It is 800 here. This is what? 800. This is what? 800. This is what? 800. By way of summing up all the three, don't say that it is a distance. It's not like that. So we have to calculate each part, OA, AB, BC and CD. This is the total length. That is what the first question it is. But the entire thing is how much it is now. It is totally, it is 720 here. The total height is how much it is? 720 here. It comprises 720 units, means this is 720 units. So it divides how many segments? 1, 2, 3. There are 4 segments. It comprises 4 segments. It divides into 4 segments. So that means 720 divided by 4, which is 180 units. So that means each part, so that means this is nothing but 180. See, this is 800. That is the length and breadth. This is the height. Height of the first part is how much? 180. Height of the first part is how much? It is 180 units, because the 720 is the height of the cuboid shape with the dimension which is given, it is 720. So the 720 will be divided as 180 units. The height of the one part of the cuboid, height of the one part of the cuboid is how much? It is 720 divided by 4, which is 180 units. So that is the first part, which is how many segments? The first segments complete at A, second segment at B, third segment at C, and the last and final segment. First, second, third and four segments meet at A, B, C and D respectively. Why I notice this? Because the changes occurs in these places which you have to notice, so that we can very well calculate what would be that. Okay. Now the first part I have given. So with this, so I have, see, if I notice this is a perfectly, it is a right angle triangle. The first part, the first segment alone, you take the first segment. So the first segment, triangle OAE. See, I have given some name for that, OABCD, and here EFGH. Okay, fine. Now the segment of this OE, OA I wish to calculate. So in your Pythagoras theorem, the squares of the hypotenuse equal to sum of the squares of other two sides. So that means AE square plus EA square. Likewise you calculate 800 square plus this is nothing but 180 square. So which we can write it as 20 into 40 square plus this is 20 into 9 square, that is 20 square into 40 square plus 9 square. 20 square into 40 square is 1600 plus 81. So here how much distance we have? It is 20 square into 1681. That could be written as 20 square into 21. That is actually here 41 square. 41 square is nothing but this. So OA square. Therefore OA is equal to 20 into 41, which is 0, 2, 1 is 2. So once again we got OA is how much? 820 units. 820 units of covering this. This is now 820 units, this OA. The first distance I found out as 820. So the same way I have to calculate other segments. Will it be same or will it be different? Let me ask the question to you. So I found out the value for this OA. So the AB, BC as well the CD, how it would be. By way of calculating whether it will be same or different. So let me tell you, here it is 800. So this is a similar triangle property. See here if I draw a line like this. So OAE, O is here, this is the like B dash, here C dash, here it is D dash. You would like take the point A B dash B, B C dash C, C D dash D. All the three triangles are similar triangle like OEA. So that means almost it is same. So how much distance you calculated, you can multiply by 4. So you can very well calculate the total distance. The total distance, here the minimum distance, minimum total length, that is the thing. Minimum total length of the escalator. That is OA plus AB plus BC plus CD which is nothing but 820 into 4, because all are similar. All are similar. Triangle OAE. So that means it is nothing but 4 8s are 32, 4 2s are 8. So this much length has to be covered, which is minimum. This is nothing but minimum length. So the total length of the escalator, which is minimum 3280 units. This is the first part we have finished. Second one, the heights at which the escalator changes its directions. So we have to calculate what is AE and what is BB dash and what is G, all that we have to calculate. What is the minimum distances? So we can calculate the first distance, how much it is here. So the second point, the heights at which the changes occurs. So we have to calculate some distances. What is the length? That is nothing but AE we have to calculate. Second point, we have to calculate F to B, that is the second point, that is nothing but F to B. And G to C. Like this we have to calculate. All the distances we have to calculate. First point AE, we have the distance, that is nothing but already it is 180 units. This is what the first one we calculated, it is 180 units for the first point here, this one. And the same thing once again it is going to occur, it is 180. So that means FB is equal to, it is already, it is nothing but 180 plus 180, which is 360 units for the second point here, this one. And for the third one, that is nothing but GC. See, first height we have calculated this, second height we are calculating from here to this, and third height we are calculating from this point. Actual point is here, the initial point to this. First here to this, second point from here to this, and third point from here to that. So that means G is to C. So that means everything we calculated from the ground level to the top. So from the ground level means first point it is 180. So till this it is, we know it is 360 plus 180, so that it is 540 units. Now there are three things takes place. One is 180, this height is 360, and here it is 540 units. So the last and final one, slope of the escalator at the turning points. So the turning points, what would be the slope? Slope means what? It's an angle. Slope means what? It's an angle. What is the definition of slope first? Let me ask you the questions. So the slope means slope of a line which makes an angle theta with the x-axis. That is what slope. So here the same thing we are taking here now. This point is nothing but a slope. Slope means it is an angle. Slope means what is that? It is an angle. Let me take the triangle is like this. This is theta, this is O, this is E, that is nothing but A. So how much angle it makes? Because here from the diagram, from the adjacent figure, triangle OAE is similar to that of triangle ABB dash. AB dash B is similar to that of triangle BC dash C, similar to that of triangle CD dash D. So this is what we have here. It is similar triangle property. So whatever angle occurs, Same thing from here, here, here. Everywhere it is same angle. So that means we wish to know what would be the angle. Angle means obviously it is tan theta. So this part already you know it is 800. This is nothing but 180 units. So from this diagram, so tan theta is equal to AE by OE. A is how much? 180. This is 800. That means it is nothing but 9 by 40. So tan theta is equal to this much, means theta is equal to tan inverse of 9 by 40. This is the angle which changes the slopes of the escalator at the turning points. So the turning points at O, turning points at A, turning point at B, turning point at C, all those points the same angle exists. So that means tan theta is equal to 9 by 40 everywhere the changes taking place by way of rotating or changing as the escalator will move the A, B and C. That is a shift that changes. There the angle would changes as 9 by 40, which is nothing but tan theta is equal to 9 by 40. That is the slope of the point. So therefore the slopes at A, B, C are tan inverse of 9 by 40, which is the slope, that is M. So with this problem is easily solved. But this is the diagram given, no need to draw. But in examination you have to draw this diagram. You have to do this approach, very simple approach. This is also easy way. I have not even taken this one, very simple way I have taken the manipulation also, because you might finding it so difficult to calculate this value. Instead I have taken very simple. This also why I have taken, it never changes anywhere. Once you calculate for 1, so you can multiply by 4. So that I have done. And here, and what would be the height of the first, second and third shift, all those things just I simply add up like 1, 2, 3, and third one, and what is the slope that we have to calculate. That also we have used the formula of similar triangle property by way of taking theta, tan theta is equal to opposite by adjacent. So we found out the slope of changes at A, slope of changes at B, slope of changes at C. So with this problem is clear for you. I think you are very clearly understood.